Welcome to Lesson 46, Simplifying Expressions with Square Roots and Higher Order Roots. We're going to start with some review on square roots. So we're just going to do a few examples here. Square root of 81, and we should all know that that is 9. And the square root of 16, which is 4. And then this negative on the outside gets tacked onto the answer because it's the negative square root of 16. The square root of 1 is 1. 1 times 1 is 1. And if we have a square root of a fraction, we can do the square root of the numerator and the square root of the denominator. So that gives us 7 over 8. And then the last one, the square root of negative 9. Now this is something that is on the second page of your notes. Actually, maybe it's not on the second page. Maybe it's just lower down on the first page. If you have an even number index, and an index is this number in the corner of the root symbol. If there is no number there, we automatically assume that it's a square root. So in this example, the square root of negative 9, we're assuming it's squared. But if we have an even number, we can't have 3, we can't do negative 3 times negative 3 and get negative 9. That doesn't work because a negative times a negative is a positive, so that doesn't work. So there is no solution to this problem because it's impossible. Now in this box, right below, at the bottom of our screen here, I have a box in the middle that just says index, and in a moment we're going to point out all of the things in the box that are considered an index. But just to start off, if a to the n power equals b, then b to the nth root equals a. So I give you an example over here. So 2 to the third power equals 8. That's 2 times 2 times 2 equals 8. 3 different 2's multiplied together equal 8. And the opposite of that is the cubed root of 8 equals 2 because 2 times 2 times 2 equals what you started with, which was 8. So there's 3 2's equals 8. So these are kind of like inverse operations to each other. So the index is this little number in the upper left-hand corner of the root symbol. So that's an index. This over here, the n, is an index. And then the other thing I wanted you to add is that the index is the same as the exponents in the above. So here we have a 3, and there below the index is 3. Up here, the exponent is n, and down below, the index is n. And just also a quick reminder that the number or value inside the root symbol is called the radicand. So those are called the radicand, the b and the 8. So let's look at the below examples on the first page here. So we have the cube root of 125. So we have to figure out what number times itself 3 times equals 125. So let's start with 5. 5 times 5 times 5. So 5 times 5 is 25 times another 5 equals 125. So the cubed root of 125 is 5. The next example, this time the root is also a cubed root. So I happen to know that 1,000 is a multiple of 10. So we'll start, since it has 3 zeros, I'm assuming that 3 tens multiplied together will equal 1,000. And it's a negative 1,000, so we'll try negative tens. And it has to be the same. You can't do 2 negative tens and 1 positive. They all have to be negative if you use the negative. So negative 10 times negative 10 is positive 100. times another negative would be a negative 1,000. So that means the cubed root of negative 1,000 is negative 10. Now notice that goes with this rule in the box that an odd number index can yield a negative radicand. However, we'll look at another example down below, but let's start with example C here. Now we have a fourth root. So we have to figure out what number times itself 4 times equals 16. I know 4 times 4 equals 16, but it's going to have to be smaller than that. So we'll try a 2. I think 3 is going to be too big, so we'll try 2. We need 4 of them. So 2 times 2 is 4. 4 times 2 is 8, times another 2 is 16. So that works. But the final example here, example D, we have a fourth root again, and we have a negative in the box. Now we could try 3 times 3 times 3 times 3, so 4 threes, which would be 9 and 9, which is 81. But if we make these negative, all these negatives, these two will cancel and these two will cancel and become positive, so it will be a positive 81 still. So that doesn't work. So that goes with this rule that an even number index cannot yield a negative radicand. So that means this is no solution. Moving on to the next part of the lesson, this is the last new bit of information that we're going to learn in this lesson, and it's about fractional exponents. So I want you to notice the gray box here, and I want you to notice the connection between the index, n, and the denominator of the fraction. Okay, so I wanted to give you an example to kind of show you how this works. If we took x to the 1/3 power, and we held that to the third power, so we did x to the 1/3 times x to the 1/3 times x to the 1/3. Now by the power property, the product property of exponents, we would be adding the 1/3s. So 1/3 plus 1/3 plus 1/3 would equal 3/3. And 3/3 equals 1. So that would equal x. So we have x to the 1/3 to the third power equals just x. And we also have, if we cube a cubed root, then the cubes actually cancel each other out, and you're left with the radicand in the center. So we can assume that x to the 1/3 and the cube root of x are equal to each other, because they both equal, when they're both cubed, they equal x. So this is what we come up with, and this is the rule that goes with it. I know that's kind of confusing, but let me show you a couple of examples using numbers here. So in other words, the reason this comes in handy is because it helps us to solve fractional exponents. If we are faced with a number like 343 to the 1/3 power, we can rewrite this and take the denominator and make it the radicand of a root, and then put the 343 in there. So we have the cube root of 343, and that equals 7. And then you always want to check your work and make sure. So 7 times 7 times 7 is what that would come out to. 7 times 7 is 49, and 49 times another 7 is 343. The next example, we look at the denominator again of the fraction, and we make that the index of the root, and then we take the number that was being held to that 1/3 power and put it as the radicand. So I happen to know that the cube root of positive 8 is 2. So this is probably going to be a negative 2, so that it will give me a negative 8. Then I always want to check it. Negative 2 times negative 2 is positive 4, times negative 2 again is going to be equal to negative 8. So that works. So here are my answers to those two examples, and we're going to do a couple more here. We already did those two on the previous page. So in C, we're going to look at the denominator again. That's going to become the index. We put the 625 in as the radicand. We have to figure out what times itself 4 times equals 625. And I've done these on a calculator and checked them, and it equals 5. So 5 times 5 times 5 times 5. 5 times 5 is 25, and again 25, and 25 times 25 is 625. Okay, the last example here, looking at the 4, we're going to rewrite it with that as our index, and a root symbol, and a negative 1,296 for the radicand. Now I have to think back to my rule about negatives and positive indexes, odd and even indexes, sorry. And I have an even number index and a negative number, and those don't go together, so we can't solve that, so it is no solution. Okay, looking at the last example, the story problem. A box has a volume of 6,859 cubic inches. What is the length of one side of the box? So volume for a box is length times width times height. And for a cube, all of those are the same. So we could make it x times x times x, which would be x cubed. And we know that that's equal to 6,859 because that's what it tells us in the problem. So now we have to solve for x and figure out what the side is. Now one way to cancel out a cube is to do a cube root. So we would do cube root on each side because those are inverse operations, cube root and cube. Just like square root and squared are inverse operations. So those would cancel each other out, and it would just become x equals the cube root of 6,859. Now I'm going to show you really quick on a calculator that I downloaded on my iPad. This is what the calculator face looks like. And to get to a root that's not a square root, I have to click function, which is right here. And this is the screen that pops up here on the right side. So after I get to this screen, I need to choose n root, because then I can do any root that I want. Once I choose that, it'll bring me back to this page, and it'll say n root up here. Whoops. It'll say n root. And then in parentheses, I type in a 3 first, because I want the cube root, and then I type in the number that I'm looking for, which was 6,859. Press enter, and it gives me the answer, which is 19. So going back to our problem here, I know the cube root is going to be 19, so my answer is going to be 19 inches. So each side of the cube is 19 inches. Now I know I went very quickly on that because I wanted to stay under 15 minutes, but you can always go back and check those steps again for the graphing calculator and how to use the n root function. And that is the end of our lesson today. Thank you for listening and taking notes.